Hi, everybody. So I wanted to spend more time thinking about how to evaluate logarithms in your head, definitely without a calculator. But this, for example. So the idea is if you can, I want you to be able to graph this, tell me the domain and range, tell me any asymptotes and behavior. And a lot of that could be helped if you could just find some ordered pairs. So here's what we're going to do. When you're going to graph a logarithm without a calculator, you look at the base. The base here is 3, and that's going to help you tremendously because, I mean, you could, the logarithms have values for every positive number. So log base 3 of 112.98, there is an exponent that will go on 3 that will result in 112.98, but goodness knows what it is. A calculator will really help us there. But there is a way to bypass that if we can pick good numbers for us. And since this x value, our domain is a big domain. It's there's lots of numbers to choose from. We want to choose good ones. So it's all about the base 3. And right away, I know that 3 to the 0 is 1 because anything to the 0 is 1. 3 to the first is 3. 3 to the second is 9. And suddenly, 9 is pretty big. 3 to the third would be 27. And that's probably going to be outside of my graph that I'm graphing. It's probably going to be a 10 by 10 coordinate plane. Also, 3 to the negative first is 1/3. So I can really get 4 ordered pairs here. And you have to know the log counterpart to all these. All these exponents, 0, 1, 2, and -1, those are logs. 0, 1, 2, -1. And this first one untangles, or it gets converted to a logarithm as such. Log base 3 of 1 is 0 because logs are exponents and 3 to the 0 is 1. Log base 3 of 3 is 1. Log base 3 of 9 is 2. So notice the base is always 3, just like the base here is 3. It's just the exponent and the power kind of switched. So 0 here and 1 there, it got switched around. So now I look at this. I want to graph this. If I could just come up with some ordered pairs. First of all, it's a logarithm, so it has a vertical asymptote, right? A vertical asymptote at x equals -7. But what x values could I plug in to figure out the y value? Well, figure out an x value. You want these. You want x plus 7 to be 1, 3, 9, and a third. So what x value would make me have log base 3 of 1? That x value would be -6. If x is -6, then this becomes, I'm just talking about this right now, this will become log base 3 of 1. And log base 3 of 1 is 0. So this is -2 times 0, which is 0, minus 11. So it results in -11. Another choice, it would be -4 for x, because if x is -4, then -4 plus 7 is 3. And now you have log base 3 of 3, which is this. Log base 3 of 3 is 1. So this is -2 times 1 minus 11. So -2 minus 11 is -13. So you got another ordered pair. We can get 2 more. When x is 2, this is 2 plus 7, which is 9. And log base 3 of 9, well, log base 3 of 9 is 2. So now this is -2 times 2 minus 11. So that's -4 minus 11, which is -15. And then the most difficult one would be to come up with -6 and 2/3, because -6 and 2/3 plus 7 is a third. And log base 3 of a third, well, that's what this is. Log base 3 of a third is -1. So this is -2 times -1 minus 11. So -2 times -1 is +2. +2 minus 11 is -9. And then you got 4 ordered pairs, which is great. And then you could graph it. Let's put this into practice here. So here is a Delta Math assignment, and we have, let me see here. Don't I have another option to to write something. Okay, well, this one, there were no transformations. I mean, there are no transformations left or right. This plus 6, notice how it's not in the grouping symbol. So that means it's not attached to the log as an x value. It went up 6 units. But this is a log, and all logs have a vertical asymptote. And this one just is at 0. So I need to get these ordered pairs out of the way and just shuffle this over to x equals 0. And now I just need to find 2 ordered pairs. Well, right away, I should let x equal 1. Because if x equals 1, then I'm taking log base 3 of 1. Well, what's log base 3 of 1? It's 0, remember? So this is negative 2 times 0 plus 6. And that's 0 plus 6. So the answer is 1 comma 6 is 1 ordered pair. So I take my yellow dot and I drag it up to 1 comma 6. The other, I need another ordered pair. So I would just choose 3. If x is 3, then again, what's in the box is log base 3 of 3, which is 1. Negative 2 times 1 is negative 2. Negative 2 plus 6 is 4. So 3 comma 4 is a second ordered pair, and that is right here. So this is my logarithm. Notice that notice the vertical asymptote is still x equals 0. My domain is 0 to infinity. My range, as always, my range is all real numbers, negative infinity to infinity. But it looks like it might be flattening out, but it is not. It is going down. It'll keep on going down to negative infinity. The range is always negative infinity to positive infinity. And we are done. It looks like it's flipped upside down. So it's always decreasing. Anyway, submit my answer, cross my fingers, hold my breath. Yes, we got it. Let's do another one. Another log, and another base 3. Okay, so this one has a little bit more detail. It's moving to the left 4. All logs have a vertical asymptote. This one is at x equals negative 4. And then I need to find just a couple of ordered pairs. Well, what's the good choice for x? And just your eyeballs are just on this logarithm. So you would love to have log base 3 of 1 because we know that's 0. And to get that, x would have to be negative 3. If x is negative 3, then this is log base 3 of 1, which is 0. And negative 2 times 0 plus 7 is 7. So you've got an ordered pair of negative 3, 7. And we need to find another one. I'll plot that in a second. What's another choice for x? You've got 2 good choices. You could do 5, because 5 plus 4 is 9, and log base 3 of 9 is just 2. Or you could do negative 1, because negative 1 plus 4 is 3, and log base 3 of 3 is 1, etc. We'll do 5 because I feel like it is not represented as much. So when x is 5, you have log base 3 of 9, which is 2. And negative 2 times 2 is negative 4. Negative 4 plus 7 is 3. So there are 2 ordered pairs, negative 3, 7. Come on. And then 5, 3. And that will do it. Let me erase this and submit my answer. Let's do another one, but not a log. Let's do an exponent. Okay, base 4, base 5. So you're looking for powers of 5 there, powers of 2, because it's a log base 2. Hallelujah. Here is an exponential one. Okay, so this is, there's no word log here, so by default, I guess it's exponential. And it most definitely is because the domain is in the exponent spot. Since it's exponential, it will have a horizontal asymptote. Okay, horizontal asymptote. The exponential part, this is like the core of the function, I guess. The x plus 4 means it went to the left 4. But remember, the horizontal asymptote defaults at y equals 0 unless you went up or down. Well, this plus 3 right here tells me that I went up 3 units. So there is a horizontal asymptote, and it is y equals 3. Without that plus 3, it would just be y equals 0. So I need to drag this up to y equals 3. And I can also drag my ordered pairs to either side of the boundary. So now I need to find a exponent here. I'm sorry, an ordered pair. All right. First of all, right off the bat, and x can be anything because this is exponential function. Now the domain is all real. You can do any x value, and I hope you are thinking of -4. Definitely, because if x is -4, then the exponent becomes 0, and 1/5 to the 0 is 1, right? Anything to the 0 is 1, and 1 plus 3 is 4. So when x is -4, the result is +4. And then now I need one more ordered pair. You know how this is 1/5? Well, can I make that 5? Yes, I can. I can make it 5. That would flip the base only if the exponent is -1, because 1/5 to the -1 is 5. So what would the x be so that my exponent is -1? Answer, -5. If x is -5, then then the exponent is -1. And 1/5 to the -1 is 5. And 5 plus 3 is 8. So we would drag these points -4, 4, -5, 8, and then submit my answer. And we've got it. I hope that's helpful.